So now that we know how to do motors, let's talk about the next big programming component of PLCs. And this is where things will get a little complicated if you don't understand tags. But we're gonna talk about timers. Timers are huge when it comes to doing things in Allen Bradley, or in this case CCW. While I'm going to be talking about CCW, I will be talking about comparisons between that and compact logic if you are used to that setup. Again, I've already went into my global variables and I've given aliases. Keep in mind you can move these things around, so you might find it way down here or way over here, so you can move these around to find it, but look for the column that says aliases, and you can put in your different aliases for your simulator. Okay. Local variables. This is what we have right now. I'm going to delete this. This is from a last bit, just so we don't have confusion. But here's my program in ladder logic, and basically all I got is, and let me move this up here because I think there's nothing up here. Here's my lights, my red light, my yellow light, my green light. They're tied into I/O embedded digital output 0, I/O embedded digital output 1. And here's my PB1. I've already named them. Another thing is, if you look at this upper cell here, you can double click on it and put columns. So you can say enable, and I'm going to say timer. I'm going to just label them timer active, timer timing, and timer done. Because here's a rung, and this is what happens with a timer. What you need to do to get your timer, you might see up here all your bits. Click on the little arrow here, and it'll give you a drop-down menu, and then you can look for your timers. And here we have my counters and timers in one thing. We're going to only look at RTOs, TOFs, and TONs in this lecture. This one we're not going to do about. This one I'm not going to talk about because they're not in the Studio 5000 platform. I might show this at some point, but not today. But how an on-delay timer works is, as I push a button, so say this is my button, I push a button, hold it in, the timer starts timing. As long as I'm pushing that button, the timer will keep timing. And once that timer gets to its preset value, it will then time out and then turn on and turn on a done bit or a signal bit. Okay, in Studio 5000 lands, the bit that is active is called the EN bit. So, and I'm gonna do a comparison here so you know what each. This is the appropriate signifier is if you've done Allen Bradley. One thing is when you pull up the timer, and we'll walk through pulling up a timer when I do the off delay, but I want to demonstrate how all this works. So, and this would be like this, but we have a tag name. In this case, our tag name would be TON_1. That gets automatically generated. I would let the system automatically generate that for you. In Studio 5000, you can create your timers and create an array of timers. But in this, I would let this automatically generate for you. And in Studio 5000, what happens is you get three different bool bits that will show up: an enable bit, a timer bit, and a done bit. And the enable bit will tell me that basically power is getting to my timer. The TT bit is active when the timer is enabled, but it's not done yet. And then the timer done bit turns on when the timer is done timing. And it stays on as long as power is to the timer. To reset a timer, you just got to drop power. So in the case of the push button, you let go and everything resets. And if I go into my local tags and hit this plus sign, you'll see that there's multiple bits here. In Allen Bradley, in this convention, there's these time data types. However, in Studio 5000, those would just be DITs, double integers. So, so this here would be the preset. This would be a DINT. and this will be a dint. This is not utilized in the Allen Bradley, and technically there's an extra timer bit in there. So, and in the Q bit they call that the done bit. This here, this bit here will be the same as an enable bit in Allen Bradley. So just keep that in mind. Okay. This says an in bit. I would not ignore this one, but the two that we're going to program with a lot are the Q bits and this R edge bit. Okay. So I'm going to erase all those and get back to my navigation. Okay. So just this gets automatically generated as a package for any timer. Okay. So that's the structure that it's looking for when it's looking for information and data and that type of thing. So I'm going to go back into the program, and in here, because this is a slightly different, I can type in T # 5S, and that will be time 5 seconds. Okay. That is nice. In the Studio 5000, if I want 5 seconds, I have to type in 5000. So in Studio 5000, 5 seconds equals 5000 automatically, because everything is based off of milliseconds. So if you're starting to try to translate and put in 5000 there, you can do that. You just would say 5,000 milliseconds. And that would be the same as Allen Bradley. You could also go in here and say 5 minutes. Or 5M, sorry, 5M. That'd be 5 minutes. And then you can even do hours. 5H, 5 hours. So just keep that in mind that if you do the preset timer, this is time, # and 5 and whatever units behind there. Okay? So M would be minutes. And that's a preset. You don't have to do anything for the elapsed time. That's what the actual timer is going to do. But let me demonstrate how we can program with these different timers. So I'm going to go into bit. I'm going to swing this down. And I'm going to hit this little button here, and it's going to absolutely show me the timer. And I'm going to go in and just do this rising edge bit and hit OK. And it shows up. On the done bit side, that's easy. I can go in here, select the variable with my Q. Okay? But this one, if I want it to be a timing bit, I have to do a combination of 2 bits. Now, you can do this in Studio 5000 with the EN bit and the done bit, or the DN bit. But in this case, what I would do is I want this to show me when the timer has power to it on that rising edge and when it is not done. Okay? And that will turn on these lights here. But this is just a basic program to show you how timers work. So I'm going to turn on my simulator. Probably should have done that before I started recording. So I'm going to turn on my simulator. Oh, there it is. I'm going to turn the power on. Hopefully it will show up. There it is. There's my simulator. I was doing something in another class, so I'm going to delete this out. I'm going to turn my power off. Sorry, I was adding modules, so let me turn this off. Don't want it to freak out. Sorry. Let me turn the power off. So I deleted those modules. I'm downloading the program. We've seen how to download. So I kind of just restarted it up. There was a fault, but now I'm hitting run mode. So let me go back to my program. It should kick me over to my program to see. So come on, I'm connected. You can do it. So here we are. I'm going to try to get this out of the way so you can see everything. Let me hide this. Close the hide. Okay. So here's my simulator. I'm going to hold this. Basically, I'm just going to have it show up on the, let's do the timer first. So if I push the push button, you can see this starts timing. And notice the red edge bit turns on and it times. But notice once the time equals the preset time equals the elapsed time, the Q bit turns on. And notice what happens to this middle section. This goes to stays true. This goes to false, and the yellow light turns off. So this is the way to do it. To program something that it's timing. Okay. So now watch if I turn off the push button. What happens? Everything turns off. And notice what happens when I push the push button. These two turn on. And if it doesn't get to the elapsed time, if I let go of the push button, it turns off. So that's how you reset your timers. Okay? I'm going to go offline. And I'm going to do something that's a little bit different. I'm going to put in here the own timer's Q bit. So the push button has to be on and the timer can't be done. Do you think that this light will ever turn on? Let me download. I'm going to build and download. So I'm downloading. Oh, I always forget that. Sorry. Bear with me. So now let's see what happens. I'm just going to have this over here because I think you can kind of still see everything, and you can see these three lights. And I'm going to hit this push button, and I'm going to let go. And watch what happens to that elapsed time. Is it ever getting to 5 seconds? No, because once the millisecond that this becomes true, it actually resets itself. So this is a little trick to make a timer reset itself, which will come in handy when you start programming. Now, if I let go of the push button, everything turns off. Or if I just toggle it really fast, it turns off. But notice nothing turns on. And this is helpful. Let me unconnect here. I'm going to add a rung just because this is helpful if you want to add another timer. Close this for a second. And let me do timer counter. TON, notice it's TON2. I'm going to go in here and just change this to TON2. And I'm going to make this TON1Q. So basically, this timer won't start timing until this turns on. Okay? So 5 seconds. Okay. So now, let's see what it does. Probably should have built. We'll see in a second. I didn't. So, okay, so here we are. We're in my program. I'm going to go back to my simulator. And now watch this. If I turn this button on and let go, everything down here, look, I want you to look at the yellow light. It's off now because this is timing, but watch what happens in a second. It's on again. And this actually turns on, but notice it's going to keep cycling. This is how you make blinking lights. Especially in Studio 5000, it takes 2 timers and then set the one done bit, the one Q bit, as an XIO to power the other one. Because once this gets done, this bit drops, resetting this timer, which turns this off, then resets this timer. So this is how you set up multiple timers at one time, and I recommend to do this with the TON. Now, briefly, let me talk about timer off and retentive timers. Okay, I'm going to go first with the retentive timers because I kind of have the structure already set up. So I'm going to delete this rung. I'm going to delete this, and now let me go in and do the RTO timer. Okay. So notice I have an extra line here. This is a reset because with retentive timers, if you drop the rung, it's going to remember its time. So I'm going to go ahead and put time, and I'm going to say 30 seconds, okay, just so we can make a difference. Everything else programs the same way. So if I go in here, I'll double click on here, the bit, and go in and do the this bool here. All right, so now I have the retentive timer, but notice I've added a reset, something for a reset right here. So I'm gonna build and download. And if you heard a meow, sorry, that's my cat. I'm at home. For you cat lovers out there, say hi to my cat Dusty. He's wanting to learn PLCs as well. So say hi, Dusty. So never know what you're gonna find in these videos. And this will be about it. So let's just show you these timers. Notice my push button is on. I'm going to turn it off, and watch what happens this time. It stays there. The time is not timing out. And notice, let me hide this. Notice the lights are not on because the timer isn't engaged. So I'm going to go back here, hit the simulator, turn the button on, and notice everything is... Oh, I messed up on that. That should be a qubit. Sorry. So now it's timing up. That should be a qubit. My bad. Got distracted by the cat. And now the qubit turns on, the green turns on, but notice what happens even if I drop the power. That bit stays on. This is really good for like tracking runtime or just tracking overall setups. But when I first hit this button here, notice what happens. The time resets. And even if I push the push button, notice what's not happening. It's not timing, because the reset overrides anything in the end. But once I let go of the reset, then it starts timing. Okay? Let's do off delay timers really fast, because those are the other timers that you need to know. And I'm going to delete this out, and it's going to be the TOF. I'm going to go here, T:5 seconds. And once again, there's my TOF. No. This would be the falling edge, it looks like. Because off delay timers are based off of triggering once you let go of a button. So that makes sense. Go back to my queue. And let's download. Because what happens with an off delay timer, that's really good for if you have a fan in a paint booth that or a motion sensor on your lights. Once you trigger give it an input, it starts timing once it stops detecting input. So it's a way of turning something off after there's no more input going in, and we'll demonstrate that in a second. And this will be the last bit, and then I'll end this longer video. Sorry about the length. But do what I do. Watch everything in 2x, and it goes by faster. So here's my off delay. Notice the queue isn't on. I hit the push button. Notice now the queue is on. Okay? Because it technically is done. My enable's on. And now I'm going to let go of it. And notice what happens. I think I just realized for the timer off, I need to make this a XIC. So off delay timers are now set up. I had to refinagle. This is how you do a timing bit for an off delay timer. You have the queue is on and the falling edge is off. It's much easier on 5000. So, but if I click on this, notice it will not time. It just turns on the queue bit right away. And then once I turn off this push button, this is when it starts timing. And that's when that TT bit or this combination turns on and the queue turns on and then it turns off. So basically, queue on when I push a push button. So I'm in the room, leave the room, so I'm out of the room, it starts timing, come back in the room, it resets, leave the room, back in the room, leave the room, and now I'm gone for the day, and now it will time out, so the lights will turn off after me. That's the purpose of an off-delay timer. Okay? I hope this was helpful. A little bit longer video, but there's a lot to go over. Have a good day.